Hey guys, today we'll be doing LeetCode number 52, spiral matrix. It is a medium question, and before I start with the solution or explanation, what I want you to do is, obviously you've searched this video because you weren't able to do it or you wanted help. What I want you to do is come up with for loops, right? Don't think of the matrix traversal for I in range, len matrix, and then matrix I. Just come up with standard for loops and see if you can replicate this functionality. So what we'll do is we'll pick one, we'll pick two, we'll pick three. We're going from this edge to this edge, right? And then once you're done reading this row, you'll cut this row out. Now we'll say, so consider 4 edges. Then now we'll say that this has moved from here to here, right? And then we'll start reading from here. We've read all of that. Then we'll consider moving this from here to here, right? And essentially we're just shifting the borders as we add and read. Now we'll do it for here. This is the direction the matrix is supposed to go, by the way, like this. So like a spiral. Yes, 7, 8, 9, you've read it. So now you will move this from here to here. Then you have this 4 left, you'll read the 4, right? And then you'll close over here. Then you'll read this. And then you'll move these pointers to a point where they no longer can coexist and we have stopped reading the matrix. Alright, move these also. Now come up with standard for loops. There will be 4 for loops if I could give you a hint. There will be 4 for loops, and all we have to do is manipulate the very corners of the matrix. So think top, bottom, and left, right. Now pause the video here if you wanted to come up with it. I'll be starting the explanation now. Okay, so for this matrix, right, you can consider, I'll draw a sample matrix here. You can consider a 3 by 3 matrix, as I say, 3 rows, 3 columns, and we can consider this to be our left, consider this to be our right, this to be our top, and this to be our bottom. And if you notice a pattern, every time we read from, let's say, the row, right, if we read this row, then we'll change our top. So once we go from left to right, we will change our top to be decremented, right? And then if we go from our this to this and we read these 3 rows, these 3, we'll change our right to now be here, then this to now be here, right? And we'll follow that essentially. So now let's consider how we would write this out in loops. So as you can see, the first loop, very standard, we go from left to right and then we'll cut top, so we'll increment it by 1. Okay, let's do that first. We'll say left is 0, right is the very end of the matrix, so we'll say len matrix 0. Now why 0? Because if you're given a matrix, it will look like nested lists, right? And we want to get for one entry the number of columns essentially, and right is basically the number of columns, and that's how we'll get it. We'll say right is len matrix 0, top is 0, and bottom is the length of the matrix. Why the length of the matrix? Because essentially the number of 2D lists corresponds to the length, like top to bottom of the list. So if we say a matrix like this, then we would have this. Alright, and then we have an output because we have to append it to a list, right? Now we'll start with the first loop. We'll say for I in range. Well, actually, first we also have to set up the loop condition. Like I said here, these two arrows, once they cross each other, as in like once these two arrows are supposed to cross each other, we will terminate the loop. So we'll say while right, we'll say left is less than right, so they cannot cross, and top is less than bottom, so they haven't crossed either. Then we can proceed with our loops. All right, so for I in range, we'll go from left to right. That's our first loop. And keep in mind, we've done right here, and we've set the right to be like the very, so if we are given a column 1 2 3, our right is basically 3. So in the array itself, when it's represented by 0 1 2, our right is basically 1 ahead, because it is the number of columns, not the exact number of columns. It is the number of columns, right? Not the indexed version of it. So we'll say left to right, and we don't have to bother with -1 right now. So we'll go left to right. We'll simply just add it. We'll read these notes. So we'll hold our top to be the constant, because we're reading from the top array, top of the matrix, and we'll simply see the columns. So think about this as row, think about this as column. Once you're done reading the first one, like I said, we'll simply increment our top. Alright, then now we have our second loop, so we'll read from this portion, right? We'll do another loop. So for I in range, top to bottom, we'll read it now. So we'll do output.append. Now since we're reading from the rows, this time our matrix's row entry will be the I, and we'll hold the right to be the constant, right? Whatever you're reading becomes I, the way that you're going, and you have to hold a constant. In this case it's right, the next time it will be left, example, right? And then once you're done with this, we'll simply shrink it. So we'll say right minus equals to 1, because we've read it, and we'll change it, right? Now in the middle of this, we'll check again if not left, because this is a edge case. We just have to check that we are still reading a valid, like we're still reading the matrix validly. Then we can simply break out of the loop. Then again, same thing, we do another for loop for I in range, but now there's a trick. Since we're reading it from the first time, we did it left to right, right? And now if you have to read it this way, I'm sure you could have guessed it now, it is reading from right to left, so we're reading it backwards. And this is where we do the right -1, because remember, I didn't do it by index, I did it as the number itself, so not by index. Now we read it left -1 and then -1, and we read it in reverse. We'll simply add it. Now this time the constant would be bottom, right? Because we're facing the bottom of the array. Bottom -1, by the way, because bottom was also the length of the array, not the index, final index. And we'll select the column to be I, because we're doing right to left. Then we'll switch our bottom to be minus equals to 1. And again we'll run another loop. This time we'll go bottom to top. Same syntax as before. bottom -1, top -1, -1, and then we read it. This time our matrix's row will be changeable and our constant would now be left. Sorry, I forgot to put a matrix here. There you go. And once you're done with this, we'll simply increment from our left plus equals to 1. So what I did here was, we read from the bottom, we changed our bottom to be 1 more up, so we incremented it by 1, and then we read from here, so we've changed our left to also now be here. So now left and right will look at this, and we have one cell left. Then we'll come back here. We'll come back to the first part of the loop, right? Because we've ended it all here. We'll come back to the first, and now we'll read from left to right again. Left to right. And we'll read this, and then we'll move our top to be 1 plus 1. And now it will be equal, yeah, it'll be equal. So it'll be equal, and since it's equal, it will break. That is why we also have this check. If you see it, this basically catches intermediate values, at which point we've already read it. And we'll at the end just return output, and that should be our answer. So just managing the borders and reading while loops. Your first instinct would be like, maybe I should try out for I in range len of matrix, and then len of matrix I read it by doing value equals to mij. It's not that difficult, just do it by simple for loop.